Hello, and welcome back to Fun with Mr. Hall, also known as the Unending Lectures on Plate Motion. Today's episode is entitled Return to Gondwana Land. Now, before we get into all this and what this means and what you need to know for all this, we do have a few announcements that we have to go over with you. The first is that spring break starts up tomorrow on Friday, and this means that this is going to be my last lecture video for the next week or so. I know, you're all devastated, you're crying. I'm hurting too. Hold back the tears. You've got to be strong. All right? So this will be it for our videos during spring break. There will be no new videos. There will be no new homework assignments. What does this mean for you? If you're caught up, you're just free to sit back, chill, relax, do whatever it is you do during the day. If you're not caught up, you are just watching this video or you are several videos behind, this is your great time to get caught up. Get things turned in, get it all set up, so that when you come back from spring break, you are fresh and you have nothing in the back to worry about, that you are in set 100% ready to go. All right? Any questions? I don't hear any. All right, so let's move on. By the way, please stick through to the end of this video. Make sure you've watched all this video because A, it has important lessons for you, but B, also I have one more announcement I do want to make at the end of this, so please make sure you've watched all the way through. All right? Great. So yesterday, you were supposed to have read an article called A Continental Puzzle. I know the article did go up late. Some of you did message me about this. I apologize for that. It is up now. If you haven't read it yet, please go back and read it. There are two quick questions you need to answer about it, and we're going to talk about a few more questions here I want you to think about as well. So the first question is, how did Wegener use the shapes of the continents as evidence that the continents had moved? Hopefully you came up with the idea as well. He looked at this map of South America and Africa and went, these go through with this. We have this coastline here. Kind of looks like it fits this coastline here with Africa. And as it turns out, well, he went, hey, I bet those two might actually fit together. And everyone was like, man, Wegener, you're crazy. What do you know about this? You studied weather, not rocks. You don't know what you're talking about. It's weird, we'll grant you. But, that's just the nature, the mystery of things here. All right, so take a minute now and think about this question. How did Wegener use the similar mountain ranges and areas made of certain types of rock found in Africa and South America as evidence that these two continents were once connected? Well, if you read, you would have realized that Wegener noticed again, looking back at South America and Africa here, that, hey, both these areas have mountain ranges here. Not only are they similar, these mountain ranges, but they look like they're made out of the same type of rock, which, okay, is not impossible, but is really kind of weird. Except that he noticed that when you put the two continents together, those mountain ranges actually connected and made one really giant mountain range. So now I've got a giant mountain range made out of the same rock. And people were like, okay, that's freaky, that's weird, but come on, Wegener, you can't be serious that everything used to be all together like this. Absolutely not. So Wegener came up with one more piece of evidence, and he used fossils. Now, how do you use fossils? Well, as it turns out, as we've been studying, he noticed, hey look, we have Mesosaurus fossils on South America, Mesosaurus fossils in Africa. We have different types of fossils that we find on both. How is it we found it on both if they weren't at least connected at some point? And most people at Wegener's time were like, you've been drinking too much, no more of that, all right? And they threw him out and he died penniless and poor. And no one cared about his ideas. Until several years after he died, when other scientists went, hey, all this evidence that I came up with about the continents look like they fit together, the mountain ranges and the rocks look like they're the same thing, even the fossils being separated like this. You know what? All right, Wegener was right. He didn't live to find out that he was right, but he was convinced. One of his ideas that most people found crazy, that really turned people off, was this idea he came up of Pangaea. In Pangaea, Wegener believed that all the continents, since they've been moving, they must have actually been connected as one giant continent back in the day. And this is what really made everybody think he was crazy. Because, really, who would have thought? Most of the people back in Wegener's day didn't even believe that there were such things as plate movements. Even the geologists who studied rocks thought those things didn't exist. So Wegener came up with his evidence, came up with this idea. Now, we know with geologists today, we've been using other evidence to actually confirm that this continent, Pangaea, actually existed about 300 million years ago, well before the time of most of the dinosaurs that you're aware of. And ever since then, these continents have continued to move apart from each other. I don't know what that ding was, so we're just going to ignore it and pretend it didn't exist. All right. So, as we look at this, you notice that there are actually two main areas here within Pangaea. There's this northern continent up here, and there's this southern continent down here. We're going to focus on the southern continent right now. We're going to try and recreate it and use some of this evidence that Wegener came up with. Now, the southern continent has since been later called a place called Gondwanaland. Now, some of you are probably wondering where does this name come from, because it's a pretty weird name. Well, as it turns out, in the late 1800s, a European scientist was trying to come up with a name for this continent, and he was studying and he learned about this place called Gondwana, which is over here in central India. And he read about the Gondwana people. And as it turns out with the Gondwana people, and what happened is they were later taken over, and all the people were scattered about throughout the rest of India. And that's made him think, hey, that was similar to what happened to the plates, so we're going to name him after this. So that's why this area is called Gondwanaland. And this has been your moment of knowledge. I don't even want to tell you how many times I had to practice to make that work. All right, so getting back to work now. The areas in gray here show the land masses that made up Gondwanaland. And since I already know that there's a couple of you already asking, what about that northern area up there? What, did it have a name? Yes, those areas also made a name. It was called Laurasia. All right? There, you've learned new things today. Lots of new things. All right, so looking at these areas in the south that made up these land masses that made up Gondwanaland, you see that they're not all like the same distances. In some areas, they're like thousands of kilometers apart. Some areas are only a couple hundred kilometers apart. So we're going to take a look here today. So we've got this map, and I'm sorry we couldn't do this in class. If you want me to send you this so you can do it, let me know. Email me. I'll be happy to send you a copy of this paper. And so we take a look here. We have all these different landforms that made up Gondwanaland. South America, Africa, India, Australia, and Antarctica. All right. And if you notice that in between here, these dark spaces in the middle are all oceans. And in these dark spaces, all those ocean lands, they also have these lines. These lines are our plate boundaries. Now, as it turns out, when we study these lines, you already know about between South America and Africa, but all the rest of them also have mid-ocean ridges too. And remembering what we've learned, what type of plate boundaries create mid-ocean ridges? If you answered divergent, you are correct. And for bonus points, what does divergent mean? Hopefully you remember that divergent means the plates are actually moving away from each other, actually separating from one another. So, what we're going to do now is the presence of mid-ocean ridges tell us that there are divergent plate boundaries at the places where the plates meet. This means that the plates and the land masses that are part of those plates have been moving apart slowly over time. As they move apart, rock from the mantle is added to the edges of both plates. If we were to go back in time, say like 200 million years ago, what do you think the location of these land masses would be? Do you think they'd be closer together, farther apart? Do you think there'd be more ocean floor? Do you think there'd be less ocean between them? Why? Well, let's watch a quick video here and let's see what happens. So as you can see in our video here, what's going on is that, well, we're separating these, and as it turns out, as we go along here, Mr. Hall's bad take at a stop-motion video, I do apologize. We go through and we have our continents. Ta-da! continents. All right? We've eliminated all the ocean space between the plates because they didn't exist 200 million years ago. Those ocean spaces were actually created as the plates separated. So 200 million years ago, there was no ocean separating all these different continents. But now that we've eliminated what wasn't there, how can we know for sure how these land masses fit together? If you look at them, we could try and fit them together like a puzzle piece and go, okay, well, we know part of South America looks like it kind of fits in with Africa, and I don't know with India and Australia and Antarctica how that's going to fit. But if we take a look actually on the maps here, we see that there's actually markings on each of these continents, and these markings represent where different fossils were found, areas where different fossils were found. And so we can actually use that information to help us piece together what these should look like. Let's see if this stop motion video works a little better than the other one. Alright, we're fitting there. Looks like South America and Africa, India, Antarctica, Australia, and we are set. Good. And there we are. There's our completed work. I'm so proud of us. I'm so proud of all of you and all this hard work that you've put into this. But let's look at the neater version, because looking at Mr. Hall's ugly work here isn't going to help anything. Alright, so here's a map of Gondwana. Sorry, I get my accent mixed up sometimes, from 200 million years ago. This is how scientists think these land masses were arranged when they were all connected as Gondwanaland. This is based on a lot of evidence, including the evidence that we just considered. So thinking about this today, the land masses that make up Gondwanaland are separated by hundreds or thousands of kilometers. But we know from evidence we worked with today that 200 million years ago, these land masses were much closer together. As we know, plates move at a very slow rate, so it took many millions of years for the land masses to get as far apart as they are today. And that's about it. That's what I really wanted you to get out of this today, is that we've learned that plates move slowly. If we reverse engineer where the plates were, we realize that, hey, they actually used to be connected to these giant land masses. We still are dealing with divergent, convergent boundaries. And so that's a lot of things. I know we've gone over a lot here, and that's why I want to give you guys a break. We're at the end of the video. So, here's what I want you to know. I've canceled the plate motion final. There is no plate motion final whatsoever. We're done. I'm done with plate motion today. This is the last video. Don't worry about it. There's no homework assignment with it. It's over. It's done. The video's a little longer, but that's okay. So instead, when we come back from spring break, what we're going to do is we're going to start over with a brand new unit. So you're going to have a lot of new information, new things, a lot of things to study about. And I think it's something you're going to really enjoy, even being cooped up inside of your homes all day long. So that's all I have left to say here. I hope you all enjoy your spring break. I hope everything goes well with you and your families. Get some rest. Don't stress out about too much about things. If you need to talk, my email is always available. And on that note, we will see you again in mid-April. Bye, everyone.